Hello and welcome to the last session of our ROS 101 Fun Approach course delivered to you by Samir. Quick recap on what we did so far. We navigated autonomously using a pre-saved map, so we created a map at the beginning and we saved that map in the form of a PGM and YAM files, and then we used these maps to load into the ROS master, and the AMCL use that map in order for it to localize the robot through information coming from that pre-saved map and information coming from the sensors themselves. And we were introduced to autonomous navigation concepts like SLAM, localization, mapping, and control, and path planning as well. We ran the localization move base and other navigation nodes. So what we're going to do today? What we're going to do today is we are going to navigate autonomously without using a pre-saved map. So we are going to assume that we're no longer just localizing the robot, we're actually localizing and at the same time building the map. So this is an actual SLAM problem. And then we're going to create the AutoNav package or complete its development, because this is going to be part 2. And the final version of the AutoNav package should be a complete autonomous navigation package with the ability to reach different goals by placing the robot in a completely anonymous environment. So let's dive in. So as I said before, the best method for you as a ROS developer to work on a project with you not having enough experience about the technical details related to the mathematical development of the probabilistic models and stuff like that, it is wise to go through the navigation packages that were designed by the original package developers and get introduced to its aspects and try to mimic or tweak some of the parameters in order to make it work for your specific application. So this is basically what I'm going to do now. So I'm going to my home directory here, and then I'm going to investigate the move base package, right? Or well, more specifically, or not more specifically, more general version of that, which is the total bot navigation package. So I'm going to investigate that package and its different components, and then I'm going to develop my own version of the TurtleBot3 navigation package through copying some of the elements of the original package and tweaking some of the parameters in order to make that package or that new package work for my specific application. So I'm gonna go to the other locations: computer, opt, then ROS, idiotic, share. Then I'm gonna head right to the TurtleBot3 navigation. So you can find some folders here. So the CMake folders is related to the build and stuff like that. I'm not interested in that, and the package XML as well. This is part of the the build data of the package and stuff like that. So what I'm basically interested in is the other files. So we have a launch file here. We have maps. So basically the maps is where a default map for the TurtleBot3 world environment is saved. So this is basically the same thing that was saved on my home directory here. So this is basically the thing that I don't need the most because I want to navigate without a map. So let's see the other files. So let's get to the launch files, for example. So I've got an AMCL launch. So this launch file is probably responsible for launching the AMCL node, or the adaptive multicolor localization node. And I've got the move base launch. So this is basically the launch of our control module. And we've got the TurtleBot3 navigation. And this, whenever you find a launch file that actually has the same name as the package itself, so we gotta deduce that this is the main launch file. This is the big launch file that's gonna launch the other two, most likely. So let's open it up. So as we can see here, the first thing is the arguments, which are basically the constants of this launch file, like the arguments or like the parameters that are going to be passed to this launch file from the terminal, for example. So we've got the model. And as you can see here, the turtlebot3 model is that variable we used to export in the terminal. So that means that this variable we passed to the terminal is actually passed here to the turtlebot3 navigation launch, where it basically searches for the name of that model, or the turtlebot3 model. And as you can see, the default version is going to be the same version we passed to the terminal. So if I, for example, remove that and copy burger, then I'll no longer have to tell the terminal that I'm going to export that variable and call it burger, because it's already the default value of that argument in my launch file. So this is the first property that I might be interested in changing, because it's really boring to export the burger model every time I try to launch the simulation. So I'm trying to reduce the number of terminal commands in order to make the package more user-friendly, right? So these are actually the choices that you get to choose through the terminal. Once you have a default, then you're not going to actually need that. Then we have the map file, and this is the line or the argument that is supposed to load the saved map that you already saved into the map server, and the map server is going to pass that map to the AMCL node. So actually I will not need that line for my development process, because I do not want to rely on a saved map. So this is another aspect that I would change. This argument is openRViz and is set to true. And opening RViz with the simulation is quite useful for the user, so I'm going to keep that. And the argument name move forward only is set to false, which is, like having the robot only allowed to move forward. So we basically set that to false, so I'm going to leave it as is. Then we have some parameters related to the turtlebot3, which is basically most likely have to do with the spawning of the robot, maybe, because I see turtlebot3 bring up, and you got the argument, which is the model name. So it's basically like launching the turtlebot robot into our simulation. So I'm gonna keep that as is. I'm not gonna change that part because it has nothing to do with my navigational aspects, just choosing the robot. Then we've got the map server here, and the map server again relies on some arguments which has to do with the map file. So I don't need the map server to act here. I need to pass my own map coming from my own SLAM algorithm, right? So I'm going to replace that with a launch for my SLAM algorithm instead of just launching the map server. We've got the AMCL, and the adaptive multicolor localization is actually needed in order to localize the robot, so I may keep that, right? And we've got the move base part. So the move base part is the control part, and yeah, actually it launches the move base launch file that we saw earlier. And in fact, the AMCL launch file, we saw that earlier as well. So these are basically these two. So my assumption was right. I could read the designer's mind. So I could tell that this launch file here is responsible for launching the other two. So let's get back here. So I'm basically gonna keep the move base as is. I'm not gonna change it. And then we've got the RViz launch. So it's basically checking if the open RViz option is true, then I'm gonna launch RViz, which is basically a node. And yeah, we've got a node called RViz, and yeah, it's basically, I'm gonna keep that because it sounds like really cool, and I'm gonna launch RViz the same way I always do, so I'm not gonna change that. So I pretty much had an idea about what to change in that launch file. So let's check the other two. We've got the move base launch file, and as usual, we got an argument that has to do with the model of the robot. So I may change that into burger in order to, not to let the user choose the robot name. And you might keep it if you want to give the users the flexibility to choose any type of robot. So these are these like designer choices, so you have to choose which is better for the user. Then we've got some topic names that we're trying to, we are trying to, give names to the topics other than the known name, which here, for example, CMD-vel, he's trying to give it the name CMD-vel topic, and Odom is giving it the name Odom topic. Or basically, he's defining a variable called CMD-vel topic, and its default name or default topic name is CMD-vel. And not the smartest naming convention, but again, this is not a first. I was gonna call that, for example, like velocity command, for example, and its default name is the topic name, which is CMD-vel. And maybe I'm gonna call that odometry source, for example, and its default name or default topic name is odom, maybe, but this won't affect me so much. It's just a naming convention, so I don't have to stress myself about it. And the move forward only is set to false, so yeah, I'm gonna keep it that way. Then we've got the part which has to do with, launching the nodes of the move-based package. So actually, the lines I'm interested in happen to be these lines, because these lines define some YAML files, which means that there are some parameters that are passed to the move-based launch, like the costmap common parameters, and the local costmap parameters, the global costmap parameters, and move-based parameters, and something called DWA local planner parameters. So these parameters must have something to do with the task that I want to execute. So I'm basically going to focus on these YAML files when I open the config file. Remap from CMD-vel is basically here changing the name of the topic, and I'm not really interested in that part. I'm gonna keep it as is as well. Yeah, so I got what I want from this file, most likely. Let's open up the AMCL launch. And as we can see here, it's basically all about parameters of the algorithm itself, like the minimum number of particles, the maximum particles, and stuff like that. And the sensors that I subscribe to, like the scans and stuff like that. And you can actually find, or you can actually deduce why the initial pose X, Y, and I think that's supposedly Z here, are always, have the default values of 0 instead of, the actual physical location of the robot in Gazebo. And this is why we do like the offset thing here. So I'm gonna keep them as 0 for now. Yeah, most likely I'm gonna do that. If I notice that there's still a shift, then I might run or add the init pose node at the beginning of my launch file. So this is basically the launch files, and we've got the param file. And this is actually the config file, but he gave it the name param, so it's not running by the usual convention, but anyways, it's okay. So we've got some parameters here, like the maximum velocity and the minimum velocity, and the acceleration limits, and the goal tolerance. All of that has nothing to do with my task. It's just like set for the robot, so I'm not going to change that. And then we have a costmap common parameters for each type of robot. So since I'm using burger, I'll just focus on the burger file. So we've got like the footprint of the robot, the inflation radius, the co-scaling factor, stuff like that. Again, things that I'm not willing to change. The other cost maps aren't important because I'm using burger. Maybe I'm going to focus on that local planner. And you can find some other parameters that, have nothing to do with my task. So I'm going to copy them as is, most likely. Then other robots. Then here, the global cost map. And you've got the global frame, which is called map, and the update frequency. I think that part is okay for me. But then you have this parameter here, which says that the static map is set to true, and this means that the global planner or the global cost map relies on a static map, which is a pre-saved map of sorts. So I need to reset that static map variable or constant to false instead of true. So this is another change that I want to make. And by the way, do not try to change the actual Turtlebot 3 navigation stack or package. Do not try to edit these files because, first of all, you can't. These are read-only files. And even if you could edit them, there's a good reason why they're leaving them read-only, because they do not want users to, like distort their design of sorts. So I'm gonna copy all of these values in just a new package of mine. And we've got the local costmap parameters, which again, the static map is set to false by default, so I needn't worry about these parameters. They're fine by me as well. And we've got the move base parameters. Again, stuff that have to do with the controller, and the designers have already set these values, so I think they are the optimal values for me. I'm not going to change that. So what I'm going to do is that I'm going to copy these aspects. Oh, we got an RVis file here. I forgot to open that, and I think it just, yeah, it's an RVis file, so all what I need to do is to copy it as is, because it just sets the visualization of RVis and the visualization tools that I need, and I think I'll use the same visualization tools as the original package. So I need to visualize the scans and visualize the global map and the coast maps and stuff like that. So I'm going to visualize the same thing. So I'm going to copy that folder as is. So indeed, if we go here to my home directory, we will find that I already copied these files, and I've actually provided you with the updated versions attached to the session content. So we have the AutoNav package here, and I've already copied these files. So we have a launch file, we have a param file. Feel free to call it config if you want. I just copied it as param and RVis. And these are the original scripts that I kept here. So let's check out first the RVis file. You will find that I just copied the same Turtlebot navigation, Turtlebot3 navigation.rvis, but I changed the name here to AutoNav because I'm a good thief. At least when I steal something, I change its name, which actually makes me a bad thief, because you should change, more than just the name in order to, right? Copyrights here. These are the copyrights, the trademark of the original designers, whom I don't know. Anyway, let's get back here to the parameters, and this is pretty important actually. You'll find that I copied those costmap parameters that have to do with burger, only burger. And then the only thing I changed was basically the global costmap parameters here. I changed that parameter of the static map. Instead of true, I set it to false. And if we get back here to the launch file, and this is pretty important, you will find that when it comes to the move base.launch, what I basically changed is the default value here, a little bit burger, in order to make it easier for the user to just launch the main launch file and not just copy too many terminal commands. I actually also changed these find commands, because these find commands were trying to search for the parameters in the Turtlebot3 navigation stack or package, the original one. So I had to change the find command to point to the AutoNav directory or package instead of the original package, because I needed to point to the parameters I set up myself. And yeah, that was basically, these are basically the change that I did to the move base file. And when it comes to the amcl.launch, I actually changed nothing. It's the same. I trust the designers on that one. So here, the Turtlebot3 auto navigation. Actually, I made some changes here, some serious changes. So first of all, as usual, I changed the default value to be burger. And then you can find that I added a slam method here. Basically, I said that we need another source of map other than the saved map. So we gotta use the gmapping package, right? We used the gmapping package to generate the map before, but the gmapping in itself is a SLAM algorithm. So we use it, it's right, we use it to generate the pre-saved map, but I can use it online as well to generate some updates of the map as I continue moving. I'll tell you how I launched this file. Actually, this line is actually stolen as well. But I'll tell you where I got it from, right? So let's just forget the SLAM lines now. I'm gonna get to that. I let the open RViz option be true as usual, and the move forward only to be false. And you can notice that I deleted everything that has to do with the map server. So I deleted the arguments that had to do with the map server because I no longer want it. And then the TurtleBot3 part, I left it as is because I didn't need to change it. And the AMCL part, I think there was like a map server part here, which I deleted because, as I said, I no longer need the map server. And I left the AMCL file as is, but I just changed the address or the name of the package here because I don't want it to point to the launch file that's located in the TurtleBot3 navigation stack. I want it to point to the AutoNav stack, my own version of the package. We're gonna leave SLAM for now, and we're gonna focus on the move base. So I left the move base part as is. As always, I changed the pointer here to point to AutoNav instead of the navigation stack. And then the obvious option was left as is. So, and I changed the name of the package as well here in order to point to the RViz file that is located in my current directory. So when it comes to the SLAM part, as usual, well, let's just assume I'm not familiar with SLAM. I cannot design my own SLAM algorithm. This is incorrect. I actually design many SLAM algorithms using ROS, but we pretend we're beginners now. So we'll think like engineers and, just use Google. And we're gonna get to the home directory. We're gonna get to the other locations, computer, and then I'm gonna investigate that SLAM package. So I'm gonna go to opt, then ROS, Neotic, and share. And we've got the TurtleBot3 SLAM here somewhere, yeah. So we've got the same thing. We got a couple of folders. So basically the bag is going to, include some ROS bags. I'm not interested in that. I'm not interested in the CMake either or the package XML. So I'm probably interested in the 3 files, right? And I'm not even interested in the RViz folder because I already have an RViz folder of my own located in my AutoNav package. So this is basically like some visualization parameters for RViz that I don't need, because for SLAM I don't need like a visualization. I just need the visualization of my navigation tools, right? And even the global map and stuff like that are already included within my navigation package. So I'm gonna neglect the RViz part. And I'm gonna focus on the config and launch. So if you open the config here, as we said before, there are other SLAM algorithms other than gmapping. We've got the frontier exploration here, and we've got the Carto mapper. So I'm pretty interested in the gmapping because this is the thing I'm gonna use. So we're gonna find some parameters here. Actually, I'm not willing to change these parameters because the designer basically selected these parameters for a reason. There's nothing here that has to do with my navigation problem. I'm just gonna use SLAM as is. So I've got a launch file here, and this is basically what is important because I'm gonna copy some parts of that launch file and include them in the AutoNav launch file. So let's check the TurtleBot3 gmapping launch and compare it against our TurtleBot3 AutoNav launch. So I've got some arguments. The first argument is the TurtleBot3 model, and I don't need to recopy that because I already have that into my arguments here. So I will just ignore that line. We've got something called the configuration base name, and for some reason it's set to that default, and I'm not pretty sure why, but all I have to do is to copy that and place it here. So we've got, yeah, the configuration base name is set here. So I'm gonna copy it as is, as I said before. And actually, I think the gmapping launch is a sub-launch file. There's a bigger launch file here. Yeah, the Turtlebot3 slam launch is the one I should open, not the gmapping, because apparently this one has the same name of the package. So probably this is the more general one. So I should compare against this one. So I'm going to open this one and just forget about that one. So again, we had the argument name, which is model. And then here, it defined the slam method that we're going to use. And we're going to use gmapping, all right, by default, unless we want to change it to choose something else. So I'm going to copy that, and I'm going to include it right after the model name here. So I determine the argument slam method to be gmapping. And I'm giving the user the option if he wants to change that, and he should copy a separate command, or he should use a separate command for that. Then we've got the configuration base name. So I basically copied that as well. And then the RViz, open RViz, well, it's already here, so I don't need to recopy it. Then we've got some parameters related to the Turtlebot3, right, which is the bring up command, and basically I already have that, so I don't need to recopy it. Then we've got some include here, which has to do with the slam algorithm. So I think I'm gonna copy that. Yeah, I copied it as is actually. And I'm gonna use the Turtlebot3 slam. I'm not gonna change the AutoNav because AutoNav does not have a slam of its own. So I'm going to like rely on the Turtlebot3 slam. And I'm gonna use it as is because I don't need to change the parameters. I don't need to change any names or anything. So I'm gonna copy it as is. Right, so I'm basically gonna use I'm gonna launch the Turtlebot3 slam itself. I'm not gonna have my own version of slam, just a bypass. So I'm gonna, search for the Turtlebot3 slam, and I'm gonna launch the Turtlebot3 argument slam. Here means what kind of slam here. So this will be replaced by gmapping, and as I said, it will launch the Turtlebot3 gmapping.launch, which was the one we open up here. So this, as I said, would launch this by default. So I need to open that, just this. And then we've got the model. I'm gonna copy that as well as is. So that slam part will be copied as is. Then we've got the move base part, and I already have that. Sorry. No, we don't have the move base part. We just copied that. And we've got the RViz part. We already have that RViz part here, so I don't need to recopy it. So basically, what I did here was copy different parts from different areas into my own launch file in order to execute the task that I want to execute. So this is basically what I needed to do in order to build my own AutoNav package. So I got the launch files we said we would have, and actually I, made up like some mix of different launches into one launch file here. And we've got the parameters, and the RViz and the scripts are ready, so I think we're ready to test that and run it. So let's launch our gazebo world again. Yeah, the Turtlebot3. So we might do something really cool. We might add the launch of the world itself to some launch file here, and we gotta remove the export Turtlebot3 model and just set the default to burger right away. So this is one way to do it. We can actually access the simulations package here, and we might investigate the Turtlebot3 simulations, the Turtlebot3 gazebo launch files here. And what we want to launch is, the Turtlebot3 world, I guess. So we might actually copy that and just change this thing here. So yeah, I'm gonna basically steal that, and I'm gonna copy it to my AutoNav and treat it as a separate launch file here. And actually, I'm gonna, edit that and let this be burger, because really typing burger every time on the terminal just annoys me. Alright, so we copied that. So let's just turtlebot, ROS launch turtlebot3 gazebo. And instead of turtlebot3 gazebo, we'll just use AutoNav because now we're using our own version. Right, so let's try that. And voila, it's working now. I don't have to type burger anymore. Right, that was cool. So that was our first launch. Now we want to launch the Autobot3 AutoNav. Sorry, the Turtlebot3, not the Autobot. Turtlebot3. Yeah, that's a transformer spawn, and not intended actually. So I'm gonna launch that. I'm gonna open up a new tab, and I'm gonna ROS launch Turtlebot3 AutoNav. That's a long name. I should have picked something a little bit, shorter. And I actually forgot the name of the package, AutoNav. I must cut. Yeah. So that's pretty much it. So let's see what happens or what doesn't happen. Turtlebot3 AutoNav will launch. Our Turtlebot3 model is not set. That is weird. I thought I set all of them to burger. So let me check that out. Maybe I forgot to. Yeah, that's set to burger. So let's check the move base, burger. Let's check the EMCL then. There's no burger. It's kind of weird because I ran that before. Turtlebot3 bring up. Oh, the Turtlebot3 bring up launch. That was one of, the Turtlebot3 packages that we used. So, yeah, maybe I need to change that into the ROS launch file. So basically, I'm gonna open that, and yeah, this is the one. This is the problem. But actually, the argument model is set here, so it should have picked burger right away. Argument name model doc, whatever the traceback was written. The Turtlebot3 model is not set. Well, it seems that I need to add burger to some hidden file here, so I'm just gonna export it for now, and I'm gonna see where I need to change it. Then I'm gonna launch. Seems to be an error here because yeah, something is wrong. Alright, let me try that again. Yeah, the costmap is not showing up. So maybe that terminal is jinxed. I need to open up a new terminal. So I'm gonna kill that world and just repeat the operation. Right, let me check that AutoNav folder first. Make sure I'm not copying anything old or something. Yeah, I think everything is fine. We've got the move base and we've got the AMCL. Right, this time I'm gonna try to run the original Turtlebot3 world instead of my AutoNav world. Right. So cool. I'm gonna export the burger here, and I'm going to run the auto nav package. Let's see what happens. Still, there's some sort of problem. I can't really locate the problem. Alright, so let me try to launch the original navigation of Turtlebot 3. Yeah, let's try to launch that one. And it's pretty weird that this one is not actually working as well. That's pretty strange because I'm running the original source file that I couldn't even edit. Alright, so let me kill that. Alright, so let me open up a new terminal. Let's just run everything as it used to be. Like, we run the original Turtlebot 3 world. Right? And we run the original navigation package. Yeah, I forgot the Turtlebot 3, that line. So let's see what happens now. Yeah, it's running right now, so yeah, everything is good. So, right, let's kill that and try to run our own AutoNav package. Alright, it is working, so that was strange. I didn't do anything different. Right. So basically now what I'm trying to show here is that our environment is set, and you can see that our global map here is not complete because I'm using a G mapping now. I'm not using a pre-saved map. So I'm relying on the global map that has been constructed by the G mapping so far, and it's not really complete. It's no problem. It will start to complete itself as long as the robot continues to bring up new observations into its memory. So we also can notice something, that I don't need to initialize my pose, because the G mapping map is already aligned with the actual original map, because actually the pose of the robot is basically the same pose that we started the mapping with is the same. The pose that we started the mapping with is the same pose of the robot at the beginning of the navigation, so they are coincident by default. So let's try to run the navigation to goal. So I'm gonna ROS run what was this called? The AutoNav package, and what is the name of that Python file we developed? The goal pause.py. So let's run it, let's hit enter, and indeed the robot is navigating to that exact point where we want it to navigate, and you can see that our environment is starting to look more obvious as the robot moves, and we can actually use the 2D nav goal as well, because we're having RViz already. So let's just navigate to that goal, for example. And as you can see, the global coast map is being updated here. Actually, the map itself, the global map itself, is getting some updates. So yeah, this is pretty much the SLAM problem here. We're navigating and at the same time constructing a map, right? So this is basically like complete autonomous navigation for a mobile robot. And yeah, that's pretty much the end of our project. So we have this AutoNav package completed. And this concludes our exercises. So I really recommend that you go through these codes, you try to study them, and then you try to like come up with new ideas. You might make new nodes, you might add to the code, you might tweak in order to improve your performance, you might include like several goals instead of just one goal, and the robot keeps navigating between them. All right. So there are many ideas that you can use, and there are many projects that you can think of. This is just the beginning. So to sum up what we did so far in this course, we were introduced to ROS and its basic utilities. And we were introduced also to Python and how to utilize some basic functionalities that would help us, write some ROS codes that would have certain aspects and have certain functionalities that we need in order to work on our robotic projects or development or our ROS development processes. We also opened up Gazebo and understood how it works and its different aspects, its worlds, its models, how the GUI works and stuff like that. And we also got introduced to some other utilities like RVIS, for example, which is used for visualizing sensor readings, maps, paths, and stuff like that. We also started working on several projects for purely kinematic robots like the Turtle Sim simulation and fully kinetic simulations that include all the physics of a real environment like Gazebo simulations. We also created our own autonomous navigation package with aspects like SLAM, individual localization and mapping. We created some maps and we used the move base, which is basically the control module, and we used some other path planning utilities, and we created a fully autonomous navigation package for a robot. So last thing I'm going to say to you is that practice makes perfect. So you need to practice what you've learned on new projects. I gave you the basics, which will allow you to learn more stuff through navigating through the ROS wiki documentation and the e-manual for the TotalBot 3. So as long as you're practicing new projects, you're continuing to forge your skills and eventually become a very experienced ROS developer.